Imagine you are sitting in a completely empty room. There is no chair, table, air, light, nothing at all. Just empty space. For thousands of years, philosophers and scientists believed that such empty space could exist. They called it a vacuum, pure nothingness. But modern physics discovered that something is really astonishing. Empty space is not empty at all, it is more like an ocean. And what we call particles or subatomic particles like electrons, photons, quarks are actually tiny waves in that ocean. This idea is the heart of quantum field theory, one of the deepest and strangest theories that humans have ever developed. This story begins with a puzzle. In the early 20th century, physicists had two powerful theories. One was quantum mechanics, which explained atoms and particles, and the other was theory of relativity, which explained space, time, and gravity. Both of them worked beautifully individually, but they did not easily fit together. Quantum mechanics treated particles like tiny objects, and relativity treated space and time as a smooth fabric. When scientists tried to combine them, everything became confusing. Particles seemed to appear and disappear. Energy fluctuated strangely. Mathematics exploded with infinities. Something deeper had to be going on. And then came the radical new idea. Physicists began to suspect that particles might not be fundamental objects at all. Instead, maybe the universe is made of fields. A field is something that exists everywhere in the space. For example, the temperature in a room is a field. Gravity around Earth is a field. The magnetic field around a magnet is also a field. At every point in space, the field has a value. Now imagine that the entire universe is filled with invisible fields, not just one, but many different fields. There is a field for electrons, another field for photons or light. There is separate field for quarks and another one for neutrinos. These fields exist everywhere in space, even in a perfect vacuum. What is a particle then? Now comes the magical insight. A particle is just a tiny vibration in a field. Think of the surface of a calm lake. If the lake is perfectly still, nothing happens. But if a small ripple appears, you see a wave moving across the water. That ripple is not a separate object. It is simply the lake moving in a particular way. Quantum field theory says that an electron is like a ripple in the electron field. A photon is a ripple in the electromagnetic field. Quarks are ripples in the quark fields, so on and so forth. Particles are little waves of energy moving through invisible fields that fill the universe. The universe is like a cosmic ocean. You have to imagine the universe not as empty space with particles floating inside it. Instead, imagine a gigantic ocean of invisible fields filling all space. When these fields vibrate, we see particles. When they interact, we see forces. When vibrations combine in complex ways, they form atoms. Atoms combine to form molecules. Molecules form cells, and cells form life. Everything you see around you, the stars, the trees, even your own body, is ultimately made of tiny ripples in quantum fields. Even emptiness is alive. One of the strangest discoveries of quantum field theory is that even when no particles are present, the fields are still fluctuating slightly. Because of quantum uncertainty, fields can never be perfectly still. Even empty space bubbles with tiny fluctuations. Particles can appear briefly and disappear. This is called quantum vacuum fluctuations. Empty space is like a sea that is never completely calm. It constantly shimmers with invisible activity. Another beautiful feature of quantum field theory is that forces arise when particles exchange vibrations in fields. For example, two electrons repel each other because they exchange photons, little packets of electromagnetic vibration. So the electromagnetic force comes from interactions in the electromagnetic field. Similarly, the strong nuclear force comes from gluon fields, and the weak force comes from W and Z boson fields. Modern physics describes almost all known forces using this framework. In 2012, scientists at CERN confirmed the existence of the Higgs field. This field fills the universe. Particles moving through it experience resistance, which gives them mass. You can imagine it like people walking through a crowded room. Some move easily and others move slowly. The more strongly a particle interacts with the Higgs field, the heavier it appears. The ripple in this field is the Higgs boson, sometimes nicknamed the God particle. Quantum field theory is incredibly successful. It predicts experimental results with astonishing precision. For example, calculations of electron behavior match the experiments to more than 10 decimal places. Few scientific theories in history have ever been this accurate. It explains particles, forces, interactions, radiation, and even particle creation and destruction. Almost everything in modern particle physics relies on it. Quantum field theory changes how we think about reality. It suggests that reality is not made of objects, it is made of fields. Particles are temporary excitations or tiny ripples in underlying structures. In a sense, the universe is not a collection of things, it is a cosmic symphony of vibrations. Matter itself is music played by invisible fields. If ancient philosophers could hear modern physics, they might say something like, the universe is not made of solid substance, it is made of patterns of motion. The entire cosmos is like an immense ocean whose waves appear as particles, atoms, stars, and life itself. And perhaps the most beautiful realization of all this is that you are not made of solid matter. You are made of organized vibrations in quantum fields that have existed since the birth of the universe. In that sense, the atoms in your body are not separate from the cosmos. They are simply waves in the same cosmic ocean. Thank you so much for listening, and do subscribe to the Nerd, and please share the video and like the video. Thank you so much.